So this is ELEC1 2019 question 8. Okay, part A1. Distinguish between noise and distortion. Now, these are two entities that students often get confused, but what we need to realise is that there is a distinct difference in terms of definition between the two. So noise is a signal from an external source, something like a radio wave, so a signal from an external source. And it's normally unwanted. Whereas a distortion is a something like slew rate in an op-amp or clipping or crossover distortion. And so what we normally say is that distortion is a non-linear modification of a signal. And it's normally from things like components in a circuit. Okay, part 2. Identify one possible source of noise. The noise can come from a variety of things. Probably the most common are things such as motors from washing machines or vacuums, but it could be lightning. It could be a source of noise as well, but I'm going to put a motor. That's my answer, and it's the solenoid inside the motor which is the key when we start talking about noise. Okay, part 3. A signal with a power level of 5 milliwatts is transmitted down a short communication link with negligible loss. However, during transmission, it is affected by a noise signal with a power level of 0.001 milliwatts. Calculate the signal to noise ratio in decibels of the emerging signal. Now, the first thing to notice is that the units for both values that we're given here are in watts. So we're talking about power. So we're looking at the power signal to noise ratio equation, and that is SNR, not SM. Let's just get rid of that. So SNR equals 10 log to base 10 of power S over power N. And so what we've got here is 10 log 10 over 5 times 10 to minus 3. And the noise is 0.001 times 10 to the minus 3. And so that gives us an answer of 36. Let me just do that. Thinking ahead, 36.99, or let's round that up to 37, and dB. Now you've got to make sure that the D is lowercase and the B is a capital, otherwise you've got incorrect units there. Right, part B. A signal is transmitted down a copper cable communications link. The signal is attenuated and subjected to noise in the copper cable. Explain what is meant by the phrase, the signal is attenuated. Well, attenuated means loss in energy, loss in power. And so it's normally in cables for things such as heating, but we need an answer. So it's signal energy. We could have put power, but we're going to put signal energy is lost, and its amplitude is reduced. And normally due to heat loss. Okay. Part C. A copper cable communications link has a bandwidth of 1.5 megahertz, so 1.5 times 10 to the 6 hertz. It carries voice communication signals. Each voice communication channel requires a bandwidth of 3 kilohertz. What is the maximum number of these voice channels that can be transmitted on the link? So we've got a bandwidth, so a broad set of frequencies which are 1.5 times 10 to the 6 wide, and we've got individual channels that sit in that bandwidth which are 3 times 10 to the 3 hertz wide. So the equation, and you can find this on the data sheet, is NCH is equal to available bandwidth divided by channel bandwidth. So we're basically nice simple calculation, 1.5 times 10 to the 6 divided by 3 times 10 to the 3, which gives us 500 channels. Okay, D part 1. In most communication systems, it is advantageous to multiplex signals onto the communications link. One technique uses time division multiplexing. Explain what is time division multiplexing. Now this is only 1 mark, but in reality there's a fair bit of information that you might want to give. So TDM, or time division multiplexing, is where 2 or more signals take turns to access a channel. Transmission time is divided into time slots of fixed length one for each signal. In essence, what you're trying to describe is a familiar diagram where we've got maybe voltage and we've got time, and what we try to create is blocks, and these are the samples from each of the channels. And so if you can imagine, we have number 1, number 2, number 3. And number 1 is one type of communication that you want to send down this particular cable. Number 2 is the second communication link. Number 3 is the third. And so they've got their each individual time slots. But what you try to do is then repeat this process. Where these second time slots are again in order of 1, 2, and 3, and you repeat this process, and so that you can actually send 3 communication links down the same cable or channel all at the same time, but divided up in time, given their individual time slots. And lastly, part 2. What is the advantage of using multiplexing in a communications link? Well, I suppose in most companies, the one thing that they're trying to do is make things cheaper. The only thing to bear in mind is that if you put an answer like cheaper, you wouldn't get the mark. It's insufficient on its own for the mark. So you need to explain why it's cheaper. And in this particular example, it's because there are fewer cables or channels required to transmit a volume of information or data. Okay, and that finishes question 8.